Hi, my name is Sachin Takmare and you are welcome to the 8th video of this series. In the previous video, we understood how a neural network is built. But now the most important question is, how does a neural network learns and how does it make accurate predictions? The answer is by using forward propagation and back propagation. So in this video we understand what forward propagation is and what backward propagation is and what is the difference between them. First we will see forward propagation. Let us first understand forward propagation, which is also called a feed forward neural network. In this process, data flows in only one direction, from input layer to hidden layers to the output layer. Inside the network, many complex mathematical calculations takes place. Then an activation function is applied, and finally we get the output or the prediction. Since the data never moves backward, it is called a forward or a feed forward neural network. For example, let us take the same example we have already discussed. Suppose we have a data set of 100 students. For each student we have input features like CGPA and IQ, and the output is placement package in lakhs. Before giving the data to the neural network, we must perform data pre-processing. Data pre-processing means cleaning raw data and converting it into a proper format. Let us understand this with a simple example. Suppose you have an expensive car, but if you do not use a pure fuel, it will not perform well. Similarly, if we provide raw and unprocessed data to a neural network, it will not give the accurate results. Just like crude oil processed into petrol, raw data must also be processed before using it. Now let us understand the data normalization and input scaling. Suppose CGPA is out of 10 and IQ is out of 160. These values are in different ranges, so the neural network may get confused about which feature is more important. To solve this, we scale all values into the same range, such as 0 to 1. This process is called data normalization or input scaling. After normalization, we give the input to the neural network. The data flows layer by layer. The network processes it and gives its prediction. For example, a student has CGPA equals to 8.5 and IQ equals to 90. The model predicts a package of 11 lakh. But in reality, the actual package is 14 lakh. So the error is 14 minus 11 equals to 3 lakhs. This difference between actual value and predicted value is called loss or error. The function that calculates this error is called a loss function. For example, regression loss functions are mean squared error, mean absolute error, Huber loss, and few more. Examples of classification loss functions are binary cross entropy, categorical cross entropy, and hinge loss. Forward propagation only gives output. It does not learn. It cannot explain why the prediction is wrong, and it cannot improve on itself. To solve this problem, researchers introduced a powerful concept around 1986 that is called backpropagation. In backpropagation, we use the error or loss and go backward in the network, and we update the weights and biases in such a way that the error becomes small or as small as possible or optimized. This process is repeated multiple times and gradually models improves its accuracy. The algorithm used for this process is called gradient descent. In our example, the error was 3 lakhs. We cannot change CGPA or IQ because they are inputs, but we can adjust weights and biases. Updating weights and biases using error is called backpropagation. Let us understand this with a real life example. Think about your 10th board exam. You write answer, teacher check them, they point out the mistakes, and you improve in the next test. This process continues until you will get good marks. This is exactly like backpropagation. And when you simply write a board exam and get marks, that is like forward propagation or feed forward neural network. So in this video, we understood what is forward propagation, what is back propagation, how neural network learn using errors. Now we are moving to the next level. In the upcoming videos, we will learn about popular neural network architectures such as ANN, CNN, RNN, and many more. But before that, it is very important to understand some basic concepts. In the next video, we will learn what is the AI development life cycle, what are trainable parameters, what are hyperparameters, what is mean by hyperparameter tuning. If you want to continue this storytelling series, Neurons to ChatGPT, stay connected with me, follow, subscribe, and share this with your friends who are really interested to learn AI. See you in the next video of this series. Thank you for watching this video. Bye.